What is up, guys? Welcome to Barton. My name is Heinrich, and today we're going to take a look at how we can handle slope using Unity's built-in physics and rigid body 2D components. It's going to look something like this. We can move up and down slopes, the character will stick to the surface, and we can even specify a max angle that the character can move up, like that. It'll look something like this. Okay, so let's just get into it. Okay, so we'll start off with this scene. The project as it is now allows the character to move left and right and jump when we push space. It's a very simple little character controller. In the scene, we have a super basic player that has a super basic player controller script connected to it. If we open up this controller script, we can see what is happening. All the script is doing right now is moving the player left and right based on our horizontal input, flipping the player based on movement direction, and checking ground and making it so the character can jump. I will include the project as it is right now in the description if you want to work along, but if you already have a movement script, you should be able to apply the slope code to your own script. Okay, so let's first talk about how we're actually going to handle the slopes. We're going to cast a ray from the bottom of the player's capsule collider. This collider will detect ground, and it'll also detect the normal of that ground. So with this information, we can tell if the ground is at an angle or not. We are then going to adjust the character's velocity to move it along the ground. We'll also then detect corners in the slopes or where the slope changes and then adjust the velocity accordingly to keep the player stuck to the ground. We also need to make it so that if the character is standing still on the slope, he doesn't get pulled down by gravity and slowly slides down. The way we're going to fix this is by just changing the physics 2D material of the player when he's standing still to something that has a high friction. Okay, so the first thing we need to do is determine the position where we want to fire the ray from. We're going to fire it from the very bottom of our capsule collider, right here. So you could create an empty child game object and place it at that point and just reference that in the code. But we can also find this point in code using a little bit of math. So let's jump into our code. And let's start off by getting a reference to our capsule collider. So we'll say private capsule collider 2D, and I'm just going to call it CC. In our start function, we can then get this reference. So we'll say CC equals get component of type capsule collider 2D. Just like that. Next, we want to store the size of the capsule collider. The size is given as a vector 2. So let's come and declare a new vector 2. And we'll just call it collider size. In the start function, we can then say collider size equals cc.size. Next, let's declare a function called slope check. So above our check input, we'll say private void slope check, like that. This function is going to get called in our fixed update after check ground. Like that. In our slope check, we're going to start off by determining that position at the bottom of our collider. So we'll say vector 2, and we'll just call it check position. And we'll set this equal to transform.position minus the collider's y size. And to do this, we need to create a new vector 3. And for the x, we will use 0.0f. And for the y, we will use collider size divided by 2. Actually, it's collider size dot y divided by 2. From this position, we're going to do a check down and to the front and to the back. So we'll write two more functions, one for the horizontal slope check and one for the vertical slope check. So let's start with the horizontal. So we'll say private void, and we'll call it slope check horizontal, like that. And now we're going to actually pass this check position to this function. So this function has an input parameter that is of type vector 2, and we'll just call it check position again. Next we have private void slope check vertical, which also takes in the same vector 2, like that. Before we do anything in these functions, let's head back to Unity and actually create some slopes that we can try moving up and down. To easily make different angled slopes if you want to use a tile map, you can go to the sprites folder and say create new sprite and create a polygon sprite. In the sprite editor, you can then select 3 as the number of sides and then hit apply. You can then come to the custom outline and then just drag it to the bottom left, bottom right, and top right corner and then hit apply. You can then come to the custom physics shape and then just do the same. For these extra points, if you click and drag them and then hit delete, it'll delete the point. We can then hit apply again, and now we have a slope. We can come to our tile palette and then just drag this slope in. You can then go to our tile maps folder and the assets folder and then just save it there. We can now paint some nice little slopes into our scene. I'm going to go ahead and create the sprites for another slope that has a slightly smaller angle. And then just add these to my tile palette as well. Okay, so we now have 2 different angled slopes that we can use. Just like that. Okay, let's jump back into the code and see if we can detect these slopes. So in our slope check vertical function, we'll start off by declaring a raycast hit 2D. And we'll just call it hit. This is going to store what our vertical raycast hits. So we'll set this equal to physics2d dot raycast. And for the origin, we're going to use this check position that we calculated. And the direction is going to be vector2 dot down. We then need to come up and declare another variable that's going to be the slope check distance. So we'll come up to our serialize field floats and we'll say serialize field, and this is a private float called slope check distance. We can then come back to our function and pass that as the distance. And then finally we can pass in the what is ground layer mask that has already been declared beforehand. Next we can say if this raycast actually hits something. So if hit, then we want to debug.drawRay, and we'll draw it from hit.point, and this is the point where our raycast intersects the collider. And the direction is going to be hit.normal. Hit.normal returns the normal of the collider that has been hit. After this, we can specify a color for it. So we can say color dot, and I like to use green for my normals. So if we save this and then make sure that in our slope check function, we call slope check vertical and pass it our check position, we can then save this and then head back into Unity and then make sure that in our player game object we specify a slope check distance. I'm going to start off by specifying 0.5 and then we run this. And as you can see, if I zoom in here, there's this little green line that indicates the normal of the ground we are standing on. And then if we start heading up a slope, you can see the green line points away from the slope at 90 degrees. Okay, so let's head back into our code. So now what we can do is we can store the angle of our slope, and we can also store the perpendicular vector2 of our normal. So let's come up to our variables, and let's declare a private float that we will call slope down angle. We're specifying down because it's our raycast that's shooting down. And then we can also declare another private vector2 that we'll call slope normal perpendicular. And I'll just say perp for that. Back in our function, we can start off by saying slope normal perpendicular equals vector2 dot perpendicular. So this is a function that the vector2 class has where we can pass it a vector2 and it'll return a vector2 that is perpendicular to the vector2 that we gave it in a counterclockwise direction. So if we pass this hit.normal, then it should return a vector2 that points to the left when we are on flat ground. Next we can get the angle, so we'll say slope down angle equals vector2, and we can use another handy built-in function called angle. And to this we can pass hit.normal and vector2.up. So this will return the angle between the y-axis and our normal, which just so happens to be the angle between our x-axis and our slope. Next, let's just draw our perpendicular ray as well with debug.drawRay. And this time we pass it hit.point as well. And the direction is slope normal perpendicular. And the color we'll just make red. So color.red. So if we save this now, head back into Unity, and then run the game, we can see we have a red ray indicating the perpendicular to our normal. If we start heading up the slope, you can see it points down the slope. We'll use this to determine what direction we should be applying our velocity in. Okay, so next we just want to declare a Boolean that is going to keep track if we are currently on a slope or not. So we'll say private bool, and we'll just call it is on slope. We also want to come up and declare another private float that we'll call slope down angle old. Back in our function, we'll say if our slope down angle does not equal our slope down angle old, then is on slope equals true. Then after this, we want to say slope angle old equals slope angle, or slope down angle. Next, we want to come down to our apply movement function. Currently, all we're doing is we are creating our movement vector2 and then applying our movement vector2 as a velocity. Instead, we're going to have 3 different ways of applying velocity. One for if we are on flat ground, one for if we're on a slope, and one for when we're in the air. So let's start off by just writing those 3 different if statements, with the first one being if we are on the ground and not on a slope. So we'll say if is grounded and we're not on a slope, then we want to apply a specific kind of velocity. Then we'll say else if we are grounded and we are on a slope, we want to apply a different kind of velocity. And then lastly, else if we are not grounded, apply the last kind of velocity. So the last one is if we're just in the air. So we'll start off by saying new velocity dot set, and we'll say movement speed multiplied by x input. And then for the y, we'll just say rb.velocity.y. We then need to set this velocity with rb.velocity equals new velocity. For when we're on the ground and not on a slope, it's fairly simple as well. We'll start off by saying new velocity dot set, and this time for the x, it's the same. So movement speed multiplied by x input. And for the y this time, we're going to say 0.0f. And then apply the velocity. Like that. I'll just make this look a little bit better. Okay. So now when we're on the slope, we want to apply the velocity specifically in the direction of the slope. So we'll say new velocity dot set. So we'll say movement speed multiplied with slope normal perpendicular dot x multiplied by negative our x input, and we're using negative x input in this case because of the way our slope normal perpendicular is being determined. And then for the y, we'll use movement speed multiplied by slope normal perpendicular dot y multiplied by negative x input, like that. And then we just need to apply the velocity. I forgot something when we were determining the perpendicular vector 2, and over here we just need to say dot normalized. That way our vector 2 has a magnitude of 1, and then when we're moving up the slope, we'll keep the same velocity. So if we save this and try it out, you can see it's already looking a lot better. But let's check out some more possible slopes that we might have. Let's come to our tile palette, and let's just paint a couple of spikes. Like that. Let's see what happens when we walk on those. As you can see, when we reach the top, we still bounce. We don't go back down the slope. Let's check over here. Here we stick to the slope a bit better because it's not such a drastic change. So let's go ahead and fix that. Let's head back to our code. And now we're going to work on the slope check horizontal function. Let's just start off by remembering to call this from our slope check function. Like that. And in the slope check horizontal function, we're going to have two raycast hit 2Ds, one for the front ray and one for the back ray. So raycast hit 2D, and we'll just say slope hit front, and we'll have another raycast hit 2D called slope hit back, like that. And we can start off by setting the first one equal to physics2d dot raycast. And we're going to use check position as our position, transform dot right as our direction, slope check distance as our distance, and what is ground as our layer mask. And then the second one is going to be exactly the same, except we're going to use negative transform dot right as our direction. Just like that. Okay, next we can come back up to our variables and declare another private float. And this time it's just going to be slope side angle. Back in our function, we can start off by saying if slope hit front, so that means the ray pointing in the direction our character is facing is detecting a slope, we will say is on slope equals true, and then we'll set our slope side angle equal to vector2 dot angle from slope hit front dot normal to vector2 dot up. And then we can say else if instead our back ray has hit something. So if slope hit back, then is on slope is also equal to true, and our slope side angle equals vector2 dot angle, and this time it's going to be slope hit back dot normal and vector2 dot up again. And then finally we can say else if neither of those rays are detecting something, we can say slope side angle equals 0.0f and is on slope equals false. So if we save this and then head back into the game and run it, you can see that we stick to the slope wonderfully. Now before we continue, I must explain that this way of dealing with slopes is going to be consistent, but it's not going to work 100% of the time, and that is just because of the way the Unity physics system works, and the only way we're going to get better results is by using custom physics. And the reason it doesn't always consistently work is because of if we are at the edge of a slope and we're about to move over the slope, depending on how far our character moves in the next update, will determine how well it sticks to the slope. Now usually, depending on how fast your character is actually moving, it's going to be fine. But you're going to get those rare cases where In our current frame, we are right at the edge, and then in our next frame, we're quite a bit away from the edge, so we'll have a little bit of a bounce. But generally, that should not be an issue, especially for slower moving characters and for slopes that don't have such drastic changes in angles like we have here. Okay, so now let's head on to the next issue, and that is the fact that our character slides down the slope when we don't want it to. So to do this, we're going to come to our physics materials folder, and we're just going to create a new physics 2D material, or physics material 2D, that we'll call full friction. And then in the inspector for this material, we'll change the friction to just inf, and that's going to change it to the highest friction that we can. We can come back to our code, and let's declare two new variables. They're both going to be serialized fields, and they are private physics material 2D, and the one is going to be no friction, and the other one is going to be full friction. Let's just save this and head back into Unity and drag in these references before we forget. So full friction goes in the full friction slot, and zero friction goes in the zero friction slot. We can then jump back into our code and go to our slope check vertical function. After this if statement, we will say if is on slope and our x input is 0, then we can change the physics 2D material of our rigid body 2D to our full friction material. We do this by saying rb.sharedMaterial, and then we can just set it equal to full friction. And then we can say else rb.sharedMaterial equals no friction. Like that. If we head back to Unity and then run the game, oh, when dragging in your references, make sure that your game is not currently running. So let's drag full friction back into full friction and zero friction into zero friction, and then run the game. As you can see, when we stop moving, the character sticks to the slope. And basically it's working now. Next, we just need to take care of fixing our jump function so that works. And then we also need to make it so that we can set a max slope angle. So let's stop this and let's start with the jump. We'll start off by declaring a new Boolean. We'll call it is jumping. We can then come to our jump function and set is jumping equal to true. In our apply movement function, we can then add not is jumping to our first two if statements. So and not is jumping, and then and not is jumping. We then need to just take care of setting is jumping back equal to false at the appropriate time. So to do this, we'll come to our check ground function. In here, we're currently saying if the character is grounded and our rigid body.velocity.y is less than or equal to 0.01f, can jump gets reset to true. That just makes it so that we can't jump infinitely, and we can only jump once we've touched the ground again. So we're going to change this around a little bit by saying if rigid body.velocity.y is less than or equal to 0.0f, then set is jumping equal to false. Because now we're no longer jumping, but instead we are falling. And then in this if statement below it, instead of using rb.velocity.y in here, we're just going to use not is jumping. So if we save this, head back to our game and test it out, you can see that our character can jump again. We can even jump on the slopes. Okay, now let's deal with the max slope issue. Let's head back to our script, and let's start off by declaring a variable where we can store our max slope angle. So we'll make another serialized field, private float that we'll call max slope angle. We can then also come down to our private booleans and create another private bool that is going to be called can walk on slope. So is on slope will get detected even if the slope angle is too big, but we'll just turn can walk on slope off so that we can no longer walk on that slope. Let's come back to our check slope vertical function. And before we do this whole friction thing, let's say if our slope down angle is greater than our max slope angle, then we can set can walk on slope equal to false. Else we'll set can walk on slope equal to true. And then after this, where we set the friction, let's add another condition in here that is just can walk on slope is equal to true. Because if we don't give any input on a slope that has too steep of an angle, we want the friction to be 0 so that we slide down it. Let's go back down to our apply movement function and then just add can walk on slope as a parameter for the second or for the first else if. So if we save this and head back to Unity, this first slope over here should have an angle of 45. So let's set our max slope angle to 30. That means we should not be able to walk up the second slope. So don't be dumb like me and remember to remove these 2 lines of code because we don't want to apply a velocity if none of these ifs are met. So if we hop back to the game now and try it out, as you can see, we cannot move up the steep slope. We have another little issue though. As you can see, we don't slide all the way back down. There's this little space over here, and this is due to the distance of our slope check. So the steeper the slope that we're trying to go up, the bigger this distance is going to be, because the faster this ray is going to detect flat ground again, which is technically a walkable slope. So to fix this, let's head back to our code. And in the part where we set can walk on slope, we're going to set it to false if slope down angle is greater than max slope angle, or our slope side angle is greater than max slope angle, like that. So if we save this and head back to Unity, as you can see, we slide all the way back down now. Okay, now we have one more issue. When we jump onto a slope that is technically too steep for us to walk on, we can still jump. So we can still climb up this slope, like that. To fix this, all we need to do is, in the part where we set can jump back equal to true, so in our check ground function, we just have to add and slope down angle is less than or equal to max slope angle. Just like that. So if we run it now, you can see that our character can no longer jump when he's on an angle that's too steep. And that's it. We now have a character that quite reliably sticks to our slope surface, and we can even specify slopes that are too steep for our character to climb. I hope you guys managed to learn something from this tutorial and somehow managed to implement this into your projects. I was planning on adding slopes to my main tutorial series, but it's just adding a little bit too much overhead for everything else, like the enemy AI and some of the movement abilities that the character has that I don't feel like dealing with right now. So I most likely will be implementing slopes into that game eventually, but first there's some other more important things that I want to focus on before I rework the character and optimize it and then add slopes in at that point. I would like to thank everybody on the Discord server who voted for this topic. I'm sorry it took so long to come out. It was quite a lot more work getting this to work than I thought it would be. And I would also like to thank my supporters on Patreon and also the wonderful people on Patreon. And then lastly, a big special thank to Lewis for your support on Patreon. I hope you all stay safe during this peculiar time that we're having, and I also hope that you all have a wonderful day.